Okay, this is chapter 4, and this is kind of something weird because we are going to jump from statistics to probabilities. And actually, this is the bridge that I said earlier about. We said that first of all, when we deal with data, first we collect data. We collect data, right? We collect data. After we collecting data, what we do is organize data. By the way, I'm slow in terms of writing, but yeah, be patient, please. After that, what we do after organizing data, we need to see it. We need to visualize it. Maybe describe it visually, right? After that, what we do, we describe it numerically. You can tell some stories about, oh, the mean is this, the median is that, it's skewed, it's symmetric, and so on. So we describe the data. After that, and all of these, by the way, we did all of this. Most of the times in the industry, we do all of this from sample because we collected what? We collected a sample, basically. I mean, from here, basically, we took a sample out of population. So this is a sample. And we talked about sampling techniques, by the way, in chapter 1. So we took a sample in a certain way. Then we asked them questions, or we collected data from this sample in one way or another. Then we organized the data into frequency distribution to have a kind of a general picture of what's happening. Then we looked at what's happening in terms of charts. We created charts. We have histogram, let's say. Then we can tell from here that, oh, it's kind of normal. I mean, it's kind of symmetric curve, right? After that, we describe the data. We said, okay, let's find the mean. Let's find the standard deviation, SD, right? After that, we need to tell whether this sample represent the population. I mean, not represent this sample, these data. We got the conclusion that, because here we come up to a conclusion. We can say something about the mean. Oh, the mean of miles that vehicles run or something is, let's say, 200 miles a day or something. Is that applicable to the population, to the whole population, which, for example, represent the American vehicles or something, the Americans' vehicles? So we need to see whether this mean really represent the population or no. Or if we, for example, found the average salary for, let's say, doctors. We can't access all doctors, so we got a sample of doctors and we found their averages, the salaries of 100 doctor, and we found that the average was $200,000, let's say. Is that something representing the whole population or no? So we need to study that, hey, we have to do something to tell whether this one is close to the population means or no. To do this, we have to cross the bridge. This is the bridge, the probability. So it's kind of something weird. That's something weird that we're going to discuss, but it's kind of the bridge that we're going to cross from sampling to population, okay? Sometimes in business, we care or we would like to know the outcome of a decision. These are some examples. When a TV manufacturer establishes a warranty on its TV sets, there is a probability that any given TV will last less than the warranty life, and outcomes will have to be compensated. So you have to study the probability. Accountants perform audits on the financial statements of the client and sign off on the statements as accurate while realizing there's a chance that problems exist that they were not uncovered by the audit. So we have some chances that we have problems in the balance sheet or into the financial statements, whatever, right? And also maybe in a food processor manufacturer recognize that there's a chance that one or more of its product will be bad and dissatisfy the customer. So there are some chances, we are looking for probabilities that this is going to happen, right? So all of these are just examples about the decisions that involve kind of chance or probability. There's some chances here. So what is the probability? Is the chance that a particular event will occur. The chance that a particular event will occur. The probability value is always going to range between 0 to 1. What is the chance that in winter, Michigan, I mean, it's going to be rainy day on Michigan on, let's say, January, February? The chance is 70%. Okay, it's not, it's just by experience, 70%. Someone's going to say 80%. Someone's going to say 90%. Right? So the value is between 0 and 1. 80% is actually a number between 0 and 1. Why? Because 80% is basically 0.8, right? So the probability always takes values between 0 and 1. What is the chance that it's going to snow in Arizona in, let's say, where? August or June, July? 0, right? What's the chance that you're going to pass this class? 100%, probably, yeah? Which is 1 in this case, right? So when the probability is 1, that means the event is going to occur. When the probability is 0, then the event will never occur, right? So between 0 and 1, we have the uncertainty of the event. Let's represent the uncertainty of the event. If you look at the one, okay, these are the examples that we talked about. What is the experiment now? The experiment is a process, these are important definitions, is the process that produces a single outcome whose result cannot be predicted with certainty. It's a process, produce a single outcome. A single outcome. It's a process, you get a single outcome. This is important to understand what's happening in this experiment, for example. Flipping one coin. Flipping one coin is an experiment, okay? It is an experiment. And the idea is, if you flip one coin, now, if I ask you to flip a coin, what is the outcome that you are going to get? You're going to get only one outcome, okay? One outcome. You will not get two. Either you're going to get head, this is the first outcome you could get, or you're going to get tail. So you have two outcomes, actually. These are all the listed outcomes. This is everything you can get when you flip a one coin. So this is an experiment. Flipping one coin is an experiment, right? What you get, you're going to get one outcome only. But if I ask you to list all of the possible outcomes, we're going to come to this. We're going to call this one sample space. This is my sample space. Sample space. So when you implement an experiment, we know that when you do the experiment, you're going to get only one outcome, single outcome. However, we don't know what is this outcome, so that's why we are going to list all of the possible outcomes, right? If you flip one coin twice, again, if you flip one coin twice, this is one experiment, for example. If you flip the coin once, this is not an experiment. I mean, okay, in this example, we are talking about this point, this particular point. If I ask you to flip one coin twice, what is the experiment? The experiment is flipping one coin twice, not once. So if you, for example, in the process of flipping, if you start flipping one coin once, you did not finish the experiment. You just keep the outcome in your mind, and you flip it again to get the other outcome, then you put them together. When you finish the experiment, you write down the outcome. So if you flip one coin twice, either you're going to get, maybe you're going to get head and head. So this is a single outcome. Remember, this is a single outcome. Probably you're going to get head and tail. Or you're going to get tail in the first one, head in the second one. Or you're going to get tail. So all of these are single outcomes, and all of these, the single outcomes, all of them, if I put them together, this represents what? The sample space. What is the sample space? It's the collection of all possible outcomes that resulted from this experiment. The same applies to when you toss a die. When you toss a die, if you toss the die, this is the experiment, you're going to look at the outcome. Probably you are going to get one, or probably you're going to get two, or three, or 4, or 5, or 6. All of these are the outcomes of implementing or doing a single experiment, okay? And as we said, the sample space is the collection of all possible outcomes. So in an experiment of flipping a coin once, find the sample space. We did already. This is the answer of question 1. In the experiment of flipping a coin twice, find the sample space. We did already. This is my second sample space. SS equals, sample space equals this. If customers are asked to list their choice of ice cream flavor from among vanilla, chocolate, and strawberry, list the sample space showing the possible outcome. You're going to list your choice. We ask a customer to list their choices, right? Just list your choice. So we have 2 customers, and we asked them again to list their choice. This is my experiment. I just picked 2 customers, and I did my experiment. I asked them, okay, tell me what's your choice of the flavors. We have vanilla, chocolate, strawberry. Okay, maybe the first customer is going to tell me vanilla, right? Again, what is the form of the output, one outcome of the experiment? The outcome is going to be 2 values, 2 things, because the first one's going to come from the first customer, the second one's going to come from the second customer, right? The first choice from the first customer, second choice from the second customer. This is my output for the experiment. Because I will not ask one customer. My goal is to ask 2 customers. That's why we have to wait to listen to both of them to get 2 values. One from the first customer, the second value from the second customer. That's why we can put them between parentheses. First one represent the first customer, second one represent the second customer. Maybe the first customer is going to tell me vanilla. Second customer is going to tell me vanilla as well, right? This is one chance that we may get. Maybe the first customer is going to tell me vanilla, the second customer is going to tell me chocolate. Or first customer going to tell me vanilla, second customer is going to tell me strawberry. Or maybe first customer is going to tell me chocolate, second customer is going to tell me vanilla. Chocolate, 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 strawberry. What else? Strawberry, vanilla, strawberry, chocolate, strawberry, strawberry, right? So basically, these are all possible outcomes, right? Do we have any other outcomes we may get? If you ask any two customers, you must get one out of these outcomes. There is nothing we left behind. We can represent this using a tree. We can put the first customer here. Let's say customer 1. What are the choices that customer 1 is going to choose out from? Maybe he's going to say vanilla, or chocolate, or strawberry. If he chooses vanilla, let's write here the second customer, customer 2. If the first customer chooses vanilla, the second customer can choose either vanilla or chocolate or strawberry. If the first customer chooses chocolate, the second customer may choose again either vanilla, chocolate, strawberry. If the first customer chooses strawberry, the second customer may choose again vanilla, chocolate, strawberry. So what is a single outcome? The single outcome, the first customer may choose vanilla, the second customer may choose vanilla. This is VV. Or the first customer is going to choose vanilla, the second customer is going to choose chocolate, so VC. Or the first customer is going to pick vanilla, the other one is going to pick strawberry, so VS, right? And continue doing all of this to get the same answers we got here. So this is the sample. These are very important concepts that we need to understand. Let's continue. Now there's another important concept we need to go over, which is the event. The event is a collection of possible outcomes. It is because we have two different things, event and the probability of the event. Okay, so we're gonna have two different things. Again, the event is what's happening actually, or what we are willing to happen, and what is the chance of that event to occur. Okay, let's look at this scenario. The KPMG is an accounting firm. They're interested in the sample space for 2 randomly selected audits. Okay. In which the outcome of interest is the audit's completion status. This is the outcome this is the thing that we care about. We need to know the status of the audit completion. Is it early, on time, or late? Okay, so we need to select 2 randomly audits. So the sample space is the list of all possible outcomes from the experiment. We know this. The accounting firm is also interested in specifying the outcomes that make up an event of interest. Okay? So define the experiment. What is the experiment? The experiment is just, excuse me, it's just selecting 2 audits randomly. This is my experiment, selecting 2 audits randomly. List the outcomes associated with one trial of the experiment. So we need to look at one trial, just one trial of the experiment. So the outcomes can be what? Early. We can call this one E. Right? The second one is going to be the audit can be done on time, right? So E1, let's call it E1, this is E2. The audit can be done on time. Actually, let's just do the first one. The audit can be done early. I'm going to give them, E1, E2, E3, I'm going to just talk about this later. So early or on time, or what's the third one? Late. If we look at to single audit only, single audit, if we look at looking at a single audit. Again, by the way, this is not the experiment. The experiment is not a single audit, by the way. The experiment is conducting 2 randomly audits. We have to do 2. After getting 2, then we're going to look at the result. So this is important. But for a single audit, we will have one out of three options: early, on time, late. Does that make sense? Because when we list the sample space and see the sample space, now we look at the whole experiment. The whole experiment, we have two audits. So the audit one, we may get, as we said, we may get early or on time or late. So this is not the end of the experiment. This is part one. Part two, we have to continue because audit two, still we have to do audit two, right? And again, audit two, I mean, we are going to make the tree now. If the audit one is early, audit two can be early, can be on time, can be late. The same applies here. If the audit one is on time, so we're going to get early, on time, late. If the audit three is late, then we're going to get either early, on time, late. So if you list the possible outcomes, let's now look at the outcomes. Possible. Oh, this is the sample space. Sample space. All possible outcomes. If you pick two audits and you make the audit, so what you're going to get? Either both audits, they're going to be early, or they're going to be early on time. The first one early, the second one on time. Or maybe the first one is early, the second one late. And you continue. So you have 9 possible outcomes. If you make an audit, you're going to get one out of these outcomes, of the 9 outcomes, right? You can technically call these, because everyone is an event. This is my point now. Everyone is an event. You care about these events because you care. Look, you care about the event that, oh, what's going to happen, right? All of these are events, all of these. Okay, the question is, what kind of event you care about? Which one you are looking for? The question is this. Suppose that, this is another part. You care about something. Let me just delete, let me erase some of these stuff. Suppose that, let's call these E1, E2, E3, up to E9, okay? All of these are possible outcomes. And you may think about any event that you really need to dig more. Because why you are doing the audit? Because you care to know, for example, you as a company, you would like to know which audits are late, or which ones have been done early. So you want to compensate the employees or something, or you're gonna check why these are late. So the event, you are the one who decide what is the event that you care about, the event of interest. Okay. Suppose in this problem, we care our event. Okay, the event is at least one audit is late because we need to do more investigation. So which outcomes give you at least one audit is late? So this is my big event E. We check them. E1, do we have one of them is late? No. E2, any one of them late? No. E3, any one of them late? Yes. So E3 is one of them. Comma. E4, no. E5, no. E6, yes. E7, yes. E8, yes. E9. So these are the events, or this is the event, and these are the elements of the event. So these are the outcomes that belong to this event. So we care about this event now. The question is, the next question that we are going to ask after getting the event, after understanding and knowing the event, because all of these contains at least one late, and you need to focus on these now in this example. The question is, oh, what is the probability that this is going to happen? Because this is your concern as an audit company. Do you have any chance that we are going to have late events or late audits? Because we need to analyze this and solve the problems, right? The second or the next definition is we're going to discuss is types of events. We have many types of events. One of them is the event that we call it mutually exclusive events. The two events are mutually exclusive if the occurrence of one event precludes the occurrence of the other event. So they cannot, they both of them cannot occur at the same time. The events cannot occur at the same time. For example, the event that consisting of the outcomes in which at least one of the two audits is late. The event that consisting of the outcomes in which neither audit is late. These two events are mutually exclusive. Why? Let's look at the first event, E1, big E. The event what is the event? The event that the one that we build, we decide, we wanted this event to be, or we are studying this event. So what is the event that consisting of the outcomes in which at least one of the two audits is late? We did it already. This event contains E1, E2, E3, E6, E3, look, E3, E6, E7, E8, E9. Let's look at the other event, the event that consisting of the outcomes in which neither audit is late. None of the audits are late. Let's call this one E1. Let's call the other event that we define as E2. What are the outcomes that we don't have late audits? Actually, the rest. E1, E2, E4, E5, yes, that's it. So basically, E1 and E2, can they occur at the same time? They will never occur at the same time. Look at the elements. The elements of E1, none of them is in E2. The elements is in E2, none of them is in E1, right? So these two events are mutually exclusive, okay? Or sometimes we call them disjoint. Disjoint, okay? So this is an example of mutually exclusive events. We need to know when the events are disjoint and they cannot occur at the same time. The other types of events, we call them independent and dependent events. The independent events, two events are independent if the occurrence of one event doesn't influence or doesn't impact the probability of the occurrence of the second event or the other event. These are, we call them independent events. However, the dependent events, they are dependent if the occurrence of one impacts the probability of the other event occurring. Let's look at examples. So determine whether these events are dependent or independent, because these are important concepts, by the way. You flip a coin and then roll a fair six-sided die. Again, you have to look at this. This is one experiment, by the way. This is one experiment. You have a coin, you have a die, and we roll this one, we flip that one. Then we record the outcome. Then we do it again if you would like to do it again. But the idea is we need to know the list of all outcomes. But it's one experiment, single outcome. Single outcome, you're going to get a number from the coin, you're going to get a number from the die, or I mean head or tail, and I mean the outcomes they're going to be recorded like they will be recorded like head, comma 1, head, comma 2, and so on, right? So this is your experiment, right? So the coin lands heads up, and the die shows 1. This is my event now, right? These are my events. The coin lands heads up. The die shows 1. Are these two things has an impact on each other's or no? Nothing. So these are independent events. A box of chocolate contains 5 milk chocolate and 5 dark chocolates, 5 white chocolates. You randomly select and eat 3 chocolates. The first piece is milk, the second is dark, and the third is white. So when you select the first one, when you selected randomly the first one and you got something, is it going to affect the probability of it's going to have any impact on the probability of having the second one or no? You have 5 milk chocolate, you have 5 dark chocolate, and you have 5 white chocolate. And you want to eat 3. You randomly selected one of that box. The first one you got was milk chocolate, right? If you now we want to select the other one, is it going to have an impact on the probability of selecting the second one? Yes, because we're going to have less milk chocolate, so it's going to have less probability to be chosen again, right? So these are dependent events. A company has 20 employees. The manager decides to fire the first 2 employees he meets in one day. Bad manager. He met the accountant, manager, and the secretary. Wow. So are these dependent or independent? Actually, they are dependent, because if you meet the accountant, right? If you meet someone at the beginning, 1 out of 19, so the second person you're gonna meet has more probability to be chosen, right? So these are dependent. Or let's say the secretary would have more chance to be chosen because at the beginning they were 20, but now they are 19. So he's going to be chosen. Maybe he has more probability to be fired. So they are dependent events. A business professor decides to give 5 extra credit for a randomly selected student each of his 4 sections. These are independent or dependent. What do you think? independent. Why? Because 4 different sections. Because he's gonna select one of this section, one of this section, one of this section, one of this section. If he select that one, it has no impact on this one, no impact on that one, no impact on that one. Okay? So these are the events. Next video, I'm going to talk about events and probability, and we're going to make a connection between these two things. Thank you.